Good morning, students. This will be your lecture 10 of concrete technology. So if you remember last class we started a new chapter, that's aggregate. We studied about the properties of aggregates, where we studied mainly about how the shapes affect the strength, and how the shape is going to affect the concrete type, concrete quality. We studied about texture, rough, smooth texture, and now we are going to see about the strength. Okay, let us start. So strength is also a very important factor in terms of concrete, because only cement, the strength of cement is not only the important part. Even the strength of the aggregate should be good. Like the aggregates that we use should be strong enough to handle any impact or any kind of impact forces or compression forces. So let us see. Strong aggregates are required for making strong concrete. Okay, so obviously if we want to make strong concrete, we need to have strong aggregates too. Strength of aggregate is measured by aggregate crushing value test. So you need to remember this test name. Okay, how are we going to determine, how do we know that our our aggregate is strong enough or not? So in order to measure the strength of the aggregate, we perform crushing value test. Now there are other important tests also. Other important tests are also carried out to measure, like their names are Dory abrasion test, Devil attrition. Sorry, this is ATT. Okay, please make this correction. This is attrition test and Los Angeles test. But then the main test that we perform in order to check the strength of the aggregate is the crushing value test. We will be performing that test, and when I'll explain you the test, I'll even show you the video. That way your concept will be clear. So now let us move to a very important property of aggregates, that is bulk density, or we also call it unit weight of an aggregate. So before we start, what is bulk density? I'm sure you must have studied in your lower grades. What is density? What is density? Everybody knows that it is a ratio of mass upon volume, right? So mass upon volume, ratio of mass upon volume is known as density. So what is bulk density? Bulk density will be the mass of, whose density are we calculating? We are calculating aggregate. तो किसका mass होगा? Mass of aggregate divided by volume of aggregate. So that is known as bulk density. It's very easy. You just need to add the word aggregate. You already know what is density. So instead of saying mass upon volume, we'll say bulk density is mass of aggregate to the volume of aggregate. Okay, so that is your bulk density. And what is its unit? Unit will be kg per liter. Kg, why kg? Kg came from mass divided by liter. Liter came from volume. So kg by liter. So what's the importance of bulk density? Why do we calculate bulk density in aggregates? That is because, let us see the third point. It shows how densely the aggregate is packed. Okay, see this word. It shows how densely the aggregate is packed, which means like it shows कि आपके aggregates जो है वो कितना अच्छे से packed है. Is it closely packed? Is it tightly packed? Or is it loosely packed? So that idea we can get it. Okay, so in order to understand this, let us see this diagram. Okay, let us consider this first diagram as diagram number 1, and let us consider this diagram number 2. Okay, now let us consider that both of these aggregates, okay, they are put inside a circular volume. Let us say volume of V. Okay, and both have same volume. So let us consider both have volume of VV. Okay, so both have equal volume. All right, but here you can see that aggregates are loosely packed, right? And here can you see the spaces? These are all gaps, or you can say these are voids. These are all the voids. All the places that is not occupied by aggregates, they are the gaps, or we call it voids. So here you can observe that there are more voids, whereas if you observe here, it's the same volume, but you can see that the gaps, I mean the voids, are comparatively lesser here. Okay, so voids are more in diagram 1 and lesser in diagram 2nd. Okay, so if we calculate bulk density of these two, you tell me whose bulk density will come more and whose bulk density will come less. How can we know that? See, bulk density is mass upon volume. Okay, so if you compare these two diagram, let us write here also mass upon volume. Okay, so if you compare these two diagram, you can see it clearly, okay, that both first thing, volume is same, but whose mass will be more, number one or the second one? Obviously mass will be more in the second diagram, right? Because it is closely packed. So if mass is more in second diagram, then if you calculate the density, whose density will come more? Obviously the bulk density of the second diagram will come more compared to the bulk density of first diagram. Why? Because the mass of the second diagram is more. You can see from the picture only, right? Since it has less voids, so obviously it has less voids because there are more number of aggregates that are closely packed. So mass of diagram 2 will be more. So if mass of diagram 2 is more, considering both have same volume, then obviously the density will also be more in the diagram 2nd. So that's why you can see here diagram 1 has lower bulk density, diagram 2 has higher bulk density. Why is that? Because diagram 2 has more weight of aggregates. See the second point, it has light weight, it has higher weight. And third point, see, it has more pore space. Yani ki it has, pore means gap. Okay, either we can say pore, we can say gap, or we can even say void. So from the diagram only you can see that voids are more present in the first diagram and less voids are present in second diagram. So from here, what did you understand? From here we can understand that considering both have the same volume, but if one of the volume has more weight of aggregate and less void space, less voids ratio, then obviously this diagram will have more bulk density. Yani ki more the weight, higher the bulk density, and lower the voids or lower the gaps. Okay, so here see I have marked in red also, you can read this. Higher the bulk density, okay, yani ki if the bulk density is higher, lower will be the void content. You can see in the diagram, lower will be the gap content, and that also makes economical mix. Economical mix. So this is like, you can understand why economical mix. Why do you think diagram 2nd makes economical mix compared to diagram 1? Why do you think so? See, because it's clearly seen that in diagram 2nd there are less voids, yani ki compared to first diagram. So if it has less voids, then even it will require less cement paste to fill up the voids, right? Whereas here it will require more cement paste to fill. मतलब कि अगर आप दो डायग्राम देखोगे, इसमें गैप कम है तो सीमेंट पेस्ट कम लगेगा इस गैप को फिल करने के लिए, वेयरएज अगर आप इसमें कंपेयर करोगे तो इसमें गैप्स वॉइड्स ज़्यादा है तो सीमेंट पेस्ट भी ज़्यादा लगेगा, क्योंकि हम वॉल्यूम जो है, वॉल्यूम तो खाली नहीं रख सकता हो। कंक्रीट का भी आपने बीच में खाली देखा है क्या? नहीं, पूरा पैक होता है ना, तो जितना भी गैप्स है वो पूरा कौन फिल करेंगे? सीमेंट पेस्ट फिल करेंगे। तो इन दोनों में से किस में सीमेंट पेस्ट ज़्यादा लगेगा? ऑब्वियसली डायग्राम 1 में लगेगा, वेयरएज डायग्राम 2 में कम सीमेंट पेस्ट लगेगा, और कम सीमेंट पेस्ट मतलब ऑब्वियसली आपके सीमेंट का पैसा बच जाएंगे। सो फ्रॉम हियर यू कैन से दैट इफ द बल्क डेंसिटी इज हायर देन void ratio, यानी कि void spaces is also less. If less void is there, then less cement paste is required. Hence we can give we can provide with economical mix. Okay, now let us see the factors affecting bulk density. Okay, number 1 is shape. Now I'm sure you must know, okay, just last lecture we studied that among all the shapes of aggregates, which shape has least voids? If you remember, it was round particles. Rounded particles have least voids. So obviously if rounded particles have least voids, then rounded particles will give greater bulk density compared to angular or subangular or flaky or elongated. Why? Because rounded particle has least voids. Least voids means greater bulk density. Okay. Second one is, let us see the second point, greater compaction. So I don't know if you have studied about compaction or not, but compaction, what do compaction means? Compaction means when you compact, okay, हम कोई भी चीज़ को जब हम उसको tightly compact करते, either by force, इसको अगर हम ज़ोर से hammer से press करेंगे या कुछ भी compact करेंगे, तो क्या है? Exactly what does compaction means? Compaction means to bring all the particles closely together by removing air voids. राइट अगर आप कोई भी मिट्टी को, ठीक है, थोड़ा पहले वो लूज है, उसमें आपने थोड़ा सा पानी लगाया और उसको ज़ोर से एक हैमर या पत्थर से मारा, तो क्या हो जाएगा? पूरे मिट्टी एक साथ इकट्ठा हो जाता है, यानी कि वो कम्पैक्ट हो गया, ऐसा बॉल बन जाएंगे, है ना एग्जाम्पल. तो आपने एग्जैक्टली क्या किया? आपने सब मिट्टी को एक साथ में लाया, अपने साथ में क्लोज टुगेदर, यू बॉट ऑल द सॉइल टुगेदर, और जो भी उनके बीच में जो भी गैप्स था, एयर वॉइड्स था, वो आपने रिमूव किया. राइट. सो सिमिलरली कंपैक्शन क्या करते हैं? कंपैक्शन वॉइड्स को रिमूव करते हैं, यानी कि जितना ज़्यादा कंपैक्शन होंगे उतना ही कम वॉइड्स होगा, और जितना कम वॉइड्स होंगे उतना ही ज़्यादा बल्क डेंसिटी होंगे. ओके, नाउ लेट अस सी द थर्ड पॉइंट. Increase in grading will give less voids, hence bulk density will increase. Now there is a new word you're seeing, okay, grading, and you really need to understand this word grading, because these are the words that you are going to use throughout your concrete technology. Forget about concrete, you are going to use these words throughout your civil engineering. So what is exactly grading? Grading means when your aggregates have all sorts of all sizes of particle, यानी कि उसमें एक ही टाइप के साइज नहीं होंगे, उसमें बड़े एग्रीगेट्स, बड़े साइज पार्टिकल्स भी होंगे, थोड़े बीच के साइज भी होंगे, बहुत छोटा भी होंगे, बहुत से छोटा भी छोटे से भी छोटे होंगे. तो सब साइज, you mean when there are all size of particles available, then we say that the grading is good. ठीक है. अब कोई में क्या होंगे? एक ही साइज का पार्टिकल होगा, ठीक है, एक ही साइज का पार्टिकल होंगे, मे बी लाइक राउंडेड पार्टिकल, तो बस राउंडेड एक ही साइज का. ये दैट इज डिफरेंट, दैट इज यूनिफॉर्म ग्रेडिंग. ठीक है. गुड ग्रेडिंग किसको बोलते हैं? जहाँ पर हर साइज है, नॉट ओनली बिग, नॉट ओनली स्मॉल, इसमें मिड साइज का भी है, मिड साइज से थोड़ा छोटा भी है, छोटे से छोटा भी है, बड़े भी है, सब है. तो ऐसे वाले पार्टिकल्स का एडवांटेज क्या है कि अगर आप हर किस्म के हर साइज ऑफ पार्टिकल्स को मिक्स करोगे तो वो क्या करेगा? जितना गैप्स जो है, छोटे छोटे गैप्स जो है, वो तो छोटे एग्रीगेट्स फिल करेंगे. राइट. तो गैप जो है, वॉइड्स जो है, वो कम से कम आपको मिलेंगे. वेयर एज एग्जाम्पल देखो, जस्ट यूज योर कॉमन सेंस. इफ़ यू यूज सेम साइज ऑफ एग्रीगेट, सेम साइज ऑफ पार्टिकल, तो ये बीच में जो स्पेसेस बच रहा है, कैन यू सी दिस स्पेसेस, ये आप फिल नहीं कर सकते. यू कैनॉट फिल दिस गैप बिकॉज योर एग्रीगेट्स आर ऑफ सेम साइज. वेयर एज इफ़ यू हैव प्रॉपर ग्रेडिंग, तो जितना भी ये गैप्स है, छोटे छोटे गैप्स, हम इसमें फिल कर सकते. क्यों? छोटे छोटे एग्रीगेट से फिल कर सकते हैं. वाई? बिकॉज वी हैव ऑल साइज ऑफ पार्टिकल्स अवेलेबल. सो ग्रेडिंग means when you have all sizes of particles available, it's called grading. So if the soil is properly grade, if it is of good grading, then it will have, obviously उसका voids जो है कम होगा, और अगर voids कम है तो bulk density ज़्यादा होंगे. Now let us see the test of, let us perform the bulk density test. Okay, we also call it unit weight of an aggregate. So how do we do this test? Okay, it's very easy. You just, for now, just know this formula. How do we calculate bulk density? Net weight of aggregate in kg. Net weight means the total weight of aggregate in kg, okay, divided by capacity of container in लीटर. यानी कि जो वॉल्यूम होगा, आप फॉर एग्जांपल आपने ये कंटेनर है, ठीक है, ये कंटेनर में आपने क्या भरा, आपने भरा एग्रीगेट्स, ठीक है, पूरा क्या भरा, एग्रीगेट्स भरा, पूरे फुल ऊपर तक भरा, ऊपर तक ही भरा आपने. तो हम इसका डेंसिटी कैसे निकालेंगे? फर्स्ट हम निकालेंगे कि टोटल मास ऑफ एग्रीगेट हमने कितना डाला, नेट वेट डिवाइडेड अपॉन वॉल्यूम. वॉल्यूम हम किसका लेंगे, हम वॉल्यूम कंटेनर के लेंगे, क्योंकि हमने एग्रीगेट्स कंटेनर में डाला है, राइट. तो बस इतना ही करना है, तो हमें अपना बल्क डेंसिटी मिल जाएंगे. एक बार ये पढ़ते हैं. Bulk density is measured by filling the aggregate in container about 1/3 each time and compacting in standard manner by stroking a tamping rod 25 times. I'll show you in video, तो आपको समझ में आएंगे. Just understand for now. हम इसको जब हम एग्रीगेट्स डालेंगे तो एक ही साथ में पूरे नहीं भरेंगे, पहले 1/3 डालेंगे. 1/3 कितना होगा, अराउंड इतना होगा, ठीक है. इतना एग्रीगेट डालेंगे, फिर उसको एक टैंपिंग रॉड से कंपैक्ट करेंगे, उसको 25 टाइम्स हम इसको टैंप करेंगे. वी आर गोइंग टू इसको रिलीज, हम एक टैंपिंग रॉड से उसको कंपैक्ट करेंगे. फिर दूसरा 1/3 डालेंगे, यानी कि 2/3, फिर से 25 टाइम्स उसको कंपैक्ट करेंगे. फिर लास्ट एक और बार उसको फुल फिल करेंगे, फिर 25 टाइम्स कंपैक्ट करेंगे. तो ये पूरा फिल हो जाएगा. उसके बाद वी आर गोइंग टू calculate the total weight of aggregate that fills the container divided by the volume of the container. I'll show you a video to make it more clear. So see, you can also go through this video from
Hello
YouTube.
viewers.
There is a link.
Concrete is the most widely used man-made construction material. It is obtained by mixing cement, water and aggregates, both coarse and fine, in required proportions either by mass or by volume. The proportions of ingredients can be converted from mass to volume and vice versa using bulk density of aggregates. Bulk density may be defined as the weight of aggregates required to fill a container of a given volume. Bulk density of aggregates can be calculated for loose weight or rodded weight. For determining the bulk density, the apparatus required includes weighing balance, either electronic or mechanical, tamping rod, straight edge, aggregate sample under test, and the observation sheet to record the readings. We also need cylindrical metal measure of 3 liter, 15 liters or 30 liters capacity. Metal measure of capacity 3 liters is used. For size of particle 4.7 mm to 40 mm, the cylindrical metal measure of capacity 15 liters is used. For size of particle 40 mm and above, the cylindrical metal measure of capacity 30 liters is used. To start the experiment, choose the metal measure of desired capacity depending upon the size of the aggregate. In this case, since the size of the aggregate is 20 mm, the metal measure of 15 liters capacity is used for the test. Take the empty weight of the metal measure.
So here you can see, first what we will do, we'll take the empty weight of the container.